Let's take a look at what our goal is. So we're looking to write a program that can parse a configuration file. Configuration files are extremely common to find on enterprise software. Most enterprise software is written to be configurable. There is no one size fits all, but this gets you somewhere. And so here are the requirements that we have for our format. We're saying that each line in our configuration file may not exceed 127 characters. All of our configuration items are key value pairs. Those key value pairs are separated by a string space, equal sign space. Each line may contain at most one key value pair. Any line that starts with a semicolon or with a pound sign is considered comment and should be ignored. And lines that don't match that key value pair definition with the space equals space should also be ignored. And so here you see an example, not counting these lines. These are just delimiters so that we can separate the example from the text. But this is the configuration file format. These lines is ignored because it's comment. So is this one. See the first characters. Then this line here does not match our format, so it's also going to be ignored. But this one does. And the key is in this case student. The value is student A. Same thing here, another key, student, another value, student B, and then etc. We go through the list. So that's what our program will need to be able to parse. Let's go see how we would do that. We already created our makefile, and our makefile basically specified that if we want to have the binary config parser, we need the input file config parser.c, and we started that, config parser.c. We started it here. So where do we begin next? Well, first, what we know is that we will need to go do some file stuff because we are loading from a file. That doesn't need anything special, but we are going to be playing around with strings as well, and that means that we will need the string library as well, the string header file. Let's go give it our file name. Now remember, in C, a string is an array of characters. And in this case, we'll call our array of characters file name. And the characters that we're initializing with are called config.text. If we define it this way, then C will prepend, postpend really at the end, the null character to signify the end of the string. So that's a good start. Now let's say that we want to have a function that does this because that's the right way to do it. You don't necessarily want to drop everything in your main function. Let's say that we're going to create a function called parseConfig, and that is going to take in the file name containing the file that we want it to parse. And by doing it this way, by giving it a file name as an argument, we could call it multiple times for different configuration files. It would also be useful to know how many configuration file items were found. So let's have it return a number. And we're just going to initialize that here as a 0. Okay, there's a couple things that could happen, such as we could be asking for a file name that does not exist. And let's say that we're going to return a value of -1 if that is the case. So we're going to say if parsed equals -1, then we can actually go and send a message, but not just any message. We're going to send a message specifically to our output standard error stream. And what are we sending there? We're sending a string that says the file name that you gave us, so %s, a placeholder, cannot be opened. And what is that placeholder? Well, that is going to be the file name. And since we can't open the configuration file, there's no point in continuing, so we're just going to return the program from that point on. Okay, that seems reasonable so far. Now note, we're using an fprintf function here. That is a string parsing function. That's why we need this library. And in this particular case, we're printing to a particular file stream. That's the first F, and that file stream is called standard error. In C programming, you separate error messages from actual output by sending your actual output to standard output and your error messages to standard error. Now, this won't compile at the moment because we don't have a parse config file yet, but we can create one. We know that it needs to return a number, and we're just going to define it as a file name. And for now, we're not just going to do anything yet. We're just going to have a placeholder, see if stuff compiles. A couple things though. Notice that down here, I defined it as an array of characters. I did not specify a size because I immediately initialized the string. And that's helpful because at that point, C will know how much space to allocate at define time. That only works if you assign the value at definition time. Otherwise, you can't do it this way. In the function header, we don't repeat the array. We just say, okay, there's an array of characters somewhere, and here is this memory address. Go find your characters there. So we don't need to specify how long the string is. We're just going to say there's a string there, go use it. And since we're not intending to change that string, let's make it a constant so that if we do accidentally make changes, the compiler will warn us. Okay, so let's call our makefile. Okay, no errors, but also no output because we haven't actually created any output yet. The good news is also no error messages. And that's because we haven't returned the value -1, even though there is no file. So let's start doing that. Let's start saying that we want to have a file. And as we saw before, if you look through the lecture slides, which of course you did, you know that we define a file in C as a file pointer. So file in all uppercase and then *F. So F is a pointer to a file. And we're going to open that with a file name. And in this case, we're only looking to read from the file, so that's good. If we read the manual file closely for C, then we will see that, actually, let's do it, man f open. And so when we read all of these words here, first we see file f open. The first thing we pass through is the path name, the file that we're trying to open. The next one is the mode in which we're opening it. And at the bottom, the return value, it says upon successful completion, f open returns a file pointer. Great. Otherwise, null is returned. And that's what we're interested in here. So let's go back to our file and say if f equals null. Well, at that point, we were unable to open our file. And what we said is we're going to return the value of -1. We don't know why. It could be that the file doesn't exist. It could be that we have no permissions to do it. It could be that the operating system is having some other breakdown happening. But that's fine. Now, since we now have one execution path, we do need to end here, signifying that everything is in order. And so let's compile and see what happens. And now it says config.txt cannot be opened. And why not? Well, because I said we're going to load config.txt and we haven't created that file yet. So let's go do that. And the easiest way to do that is by taking our instructions here, those, and just copying those to config.txt. We really don't need to do anything else because all the lines that don't match our format should be getting ignored. But just let's not push it right quite now. Let's do this. And now we can run our program again. Good. No output, no errors, all is good. So back to the program. So at this point, we have defined our file name, initialize our counter to 0, called the function, check to make sure that we were actually opening the file correctly. And so that is what we did in the function, right? So we said open the file, and if that doesn't work, return -1. Now we said the function needs to return the number of items that were read. So let's go get a counter and start it at 0. And then in the end, we're not going to return the value 0, but the value stored in the counter. That's a better way of doing it. And at this point, all we have to do is just start reading from the file. And the idea is that we will continue reading from the file, one line at a time, until there is nothing more to read. And nothing more to read could mean that we have reached the end of the file, or that some kind of an error condition has occurred. At this point, we really don't care which one it is. Now, if we don't know how long something is going to take, we typically use a while loop. In C, the function to read a string from a file is called fgetS, file get string. And so what we're going to get is, let's say, we're going to read into a line, which we still have to define. We want to know how many bytes we can read from that line, and we need to know what file to read it from. And we're going to continue doing that as long as that function call does not return null. And so that is our loop. Now, this won't work because we haven't defined line and line size yet. So let's go do that. Our instruction said line size cannot be more than 127 characters, but we need to keep one character on the side for the null terminator, so we make that 128. And over here, we need to say, okay, let's go have a string that can hold that number of characters. And so the easiest way to do that is define an array of characters of that given size. Right, so now we have defined an array of characters that we will fill one line at a time every time that we cycle through the file. And so at this point, that array of characters is filled with the first line in our text file. And so we can start looking at the first character on that line and say, well, if that is a semicolon, oh, a character is a single quote in C, a double quote is a string. But so we're looking at characters, or that line is a pound sign. Well, at that point, we really don't want to do anything. We just want to move on to the next iteration of the loop. And we do that by saying continue. So ignore everything else in this loop and just start over again. We also now want to say, does the line that we have clearly did not start, oh, that needed to be a semicolon, does not start with a semicolon or a pound sign. So now we need to see if it matches our format. Right? So key space equals space value. And to scan a string like that, C has a function called scanf. And so we can go, okay, scanf. What is the string that we're going to be scanning? Well, that's the string we just read, line. And then we are next going to say, okay, what format should that line have? Well, we said it is going to have a string, a space, an equal sign, a space, and another string followed by a new line. If you're going to match this pattern, store the first string in a string called key and the second string in a key called value. This scanf function returns the number of matches it was able to make. So in this particular case, we're only interested in counting this as a real hit if 2 matches were made. So if this equals 2. And at that point, we can increase our counter by 1. And maybe we want to say just a quick output, although that's really not really nice because you don't want to combine reading and printing, but we'll take a bit of a shortcut here. And we'll print, but this time to standard output, not to standard error, what we just found. And so once we're done with this, we go on to the next line of our string and do the same thing all over again. And we do it again and again and again, all the way until we reach the end of the file, in which case we close our file, and then we return our counter. Now this doesn't work yet because I have not yet defined key and value. What we do know is that key and value, the size of those two, plus my little string here, this one, cannot exceed 127. So it's 127 minus 3. We got to kind of figure out how we're going to divide that. And so I'm going to say, you know what, let's say that a key should be no more than 16 characters. And the value is then no more than line size minus 16 minus 3. Now that's kind of ugly, not to do it that way. So instead of this, we're going to throw key size and value size and define those at the bottom here. Key size 16 and value size 108. And now I think we have it all done. And if not, the compiler will tell us, right? So let's run through the you know what? Let's compile first. Make no errors. Run the program, and it did found 1, 2, 3, 4, 5. But we haven't tested yet if it's actually returning the correct value. So we want to say printf else otherwise printf %d configuration items found parsed. And then we really don't need this, although you could make an argument either way whether or not you want to put them there. Okay, let's recompile. We make changes, still no errors, and indeed 5 configuration items found. So that looks like our program is working. So let's take a quick look at it to make sure that we understand what we're doing. Let's turn on line numbers so we have it easy to reference. We start by including the header files we need. That is standard IO and string.h. We need standard IO to be able to print stuff, string.h to be able to do things like print, scanf, fgetS, etc. If you're not sure, we can always just log and read the manual page. And it will tell you right here that in order to do scanf, we need standard io.h. So it's helpful in that way. So we're going to define a couple of variables inside my parse config function. So let's be nice. Parses the configuration file referenced by file name. Returns -1 on failure when unable to open the file. Otherwise, the number of match configuration items. Those are the two things you always want to have in there. What does this function do? What do the arguments say? And what is it going to return at the end? Yeah, always. No matter what function you write, maybe except for your main function, you always want to say that. Even if it seems immediately obvious, make it clear. Okay. So we're going to parse the configuration file. We're not looking to change file name, which is a string, a pointer to a character array. And so we put the const keyword in front. We define our local variables. So pointer f is a pointer to a file. The counter is 0. That keeps track of how many lines we have successfully parsed. The overall size of each line that we're going to read, and we set a specific size on that so we can't overflow it. And we do the same thing for key and value. Actually, we haven't done that yet. We have not made sure that key and value are size limited, so we gotta fix that. Open the file name for reading. Make sure that went correctly. If not, abort, because there's nothing else we can do. Otherwise, start reading one line at a time. Make sure we don't read more than line size number of characters at a time from file F. If we do, then we stop our loop and we close out the file, return our findings. Ignore comments, and then here we need to be a little bit more precise and say, okay, we need to have 16s and 108s over here. There's no real good way to incorporate line size and key size there without going into more complexity than we need for this example, so we'll just hard code it here. But in this case, we can say a string of at most 16 characters and a string of at least 8 characters. Really, that should be one less because every string ends with a null character. So we'll do it that way. And if they match, store them in the variables key and value. If we match exactly 2 of those, increase our counter and print what we have found. Once we've done all of our lines, close the file and return how many files we matched. And at the bottom here, that is what we'll print. Okay, we made changes, so we'll run make, and then we run our program again, and it still works. So that is good. So what have we seen? We have seen strings. We have seen strings as character arrays, and we have seen working with files in this example.